Okay guys, we start our new unit on area, surface area, and volume today. I do want you to recognize that the first couple of pages in your note packet are reference material. We will be coming back to that, but we will be starting today's notes on page 3. Okay. All right. Now remember, a regular polygon is a any-sided figure. It's got to be a closed figure, composed of straight lines. And all of the sides and all of the angles in a regular polygon are congruent. So all sides are congruent, and all of those angles are congruent as well. Okay. So a square is a regular polygon. A rectangle is not a regular polygon, okay? Because it violates the all sides are congruent. A right triangle is not a regular polygon because it violates that all of the angles in a right triangle are not the same size. Okay? So we're talking about a very specific type of polygon that is regular. And we have some parts that we need to name. We have a center of a polygon, which is when I draw a circle around a polygon and the circle makes contact at the vertices. The center of the circle is also the center of the polygon. Okay. Now, just like circles, polygons have a radius. From the center to a vertice is the radius. Okay. And it's the distance from the center to a vertex or an angle. The next thing we have about a regular polygon is its center or central angle. Now this is very specific. If I have a radius from the center to a vertice, the very next vertice is going to make a central angle, okay, here in blue. I don't get to say that angle COA is my central angle. That is incorrect. Angle COB would be a central angle because I don't get to skip a vertice when I'm doing the center angle. Okay? So it's formed by two radii, which is just plural for radius. And it is drawn to consecutive vertices, which is plural for vertex. Okay. Now, there is a new to you word. That word is apothem, A-P-O-T-H-E-M. Excuse me. And it is the shortest distance from the center of a polygon to a side. So we have an apothem here from the center to a side. It makes a right angle, and it also bisects the side it intersects with. Okay? So those are some really important things that we need to know in order to solve area problems given regular polygons. And this is how we'll do it. A regular polygon's area is found by taking the apothem times the perimeter and dividing it by 2. Remember, perimeter is a walk around the shape, and the apothem is from the center to a side, meeting at a right angle and bisecting that side. Okay? So there are some shapes that we see over and over and over again: a square, an equilateral triangle, and a regular hexagon. You can see that my apothem from the center to the edge, creating a right angle, also bisecting that side, and a radius from the center to a vertice. This also for a square, that radius is an angle bisector. So it creates samesies on top and bottom when I draw in that radius. For my equilateral triangle, same thing. From the center to the side, at a right angle is my apothem. Bisecting that side, this radius is also an angle bisector. Okay? Shockingly enough, in our hexagon, my apothem from the center to the side at a right angle, bisecting that side, that radius r is also an angle bisector. Okay? Creating samesies on each side of it. Now there is a little formula box down here, the special formula for regular equilateral triangles. And if you want to use it, fine, terrific. But the way I'm going to show these is not by memorizing yet another formula, okay? I don't have space in my brain to keep another thing that's only good for equilateral triangles. Excuse me. I would rather have something that's going to work on every regular polygon, and it's only one thing I have to do instead of, can I use this? Can I not use this? Is it equilateral? I'm not going to make a huge point about the special formula for regular triangles. I will, however, work 3 problems on the next page. So page 4. Find the area of a square with an apothem of 6. First thing I'm going to do is draw a square. Okay, it's kind of squarish. An apothem from the center to a side, making a right angle, I am told is 6. The next thing I'm going to do is I'm going to draw in a radius of r, and that's going to create for me a right triangle. That is where we want to be, because we can do all kinds of things with right triangles. So I'm going to pull that right triangle out, so make it a little bigger. My apothem is 6, and that is my right angle. Over here is my radius, so I've just pulled that piece out. Now, my area equation, area equals apothem times perimeter divided by 2, is now going to give me a little bit of a problem, because I don't have a side measure. I'm going to have to figure that out. I need to know what this side length is. And I'm going to do that by using this side, and then I'm going to double it, because I'm going to get this side, and then I'm going to know all of the sides. And I can just walk around the shape and add them up. That'll give me perimeter. I already have the apothem, so this is my target. My target is to find the length of this side here in pink. Okay. So how am I going to do that? Well, it's a square, and I told you that this radius is an angle bisector, creating samesies on each side, and squares have all right angles. So if I cut that right angle in half, I get a 45-degree angle here. My triangles have to add up to 180. 45 plus 90 leaves me another 45 degrees here. And I have a special right triangle, a 45, 45, 90 right triangle. So let's do a quick review. Across from the 45-degree angle is our building block. Across from 45 degrees is 6. Shockingly enough, across from the other 45-degree measure, also 6. Hey, I have found my side length. And across from our 90 is our building block times the square root of 2. But I don't really need that radius, but I did want to show you guys how to work with the 45, 45, 90 right triangle, because we might need to come back to this. So I found my x. That part is 6. Congruent side is 6. Walk 6, take a break, walk at number 6. Each side is 12 units. Now, I have my apothem. I can find my perimeter. I can divide by 2. I am all set. Apothem of 6 times the perimeter, 12 plus 12 is 24, plus 12 is 36, plus 12 is 48. And I'm going to divide that by 2. And I'm going to go to my calculator and get 144. We don't have any units. Units squared, because it's area. Now, you might say, but Ms. Hart, there was an easier way. Once you know that this side is 12, we can just length times width, because that's another way to find area of a square. I agree. 12 times 12 is 144. I get the same answer. Right? But I was only given one piece of information, and then I got to figure out the rest of this. Okay? That's the difference in using the apothem measure and those special right triangles. So let's take a look at number 2. I'm to find the area of a regular triangle with a radius of 8. Okay. I've got a triangle. From the center to a vertex is my radius. I am told that that is 8. Well, on my first problem, I was given the apothem and drew in a radius. This time I'm given a radius, I'm going to draw in an apothem. Meets at a right angle, bisects that side. Okay. And how I found this right triangle angle measure, I'm not going to do anything different here to find the angle measure. I'm still going to pull out a right triangle. Okay. And this side is 8. Here is my right angle. And I'm targeting this side. I'm going to do it in blue this time. This is the side I want to find. Okay. That side. Well, all my triangle angles have to add up to 180, and I'm going to divvy that out by evenly amongst these 3 angles. So each one of these angles is 60 degrees, and that angle is bisected, cut in half by that radius. So this lower piece down here is 30 degrees. And I've got 90. That leaves me 60 degrees on this side. I have a 30, 60, 90 right triangle. So remember, across from the 30 is our building block, or our x. Across from our 60-degree angle is our building block times the square root of 3. And our hypotenuse, or across from our 90-degree angle, is 2 times our building block, or 2x. I have across my hypotenuse, across from my right angle, is 8. So 2x equals 8. I'm going to divide both sides by 2. X equals 4. That's good news. That's a building block. Across from my 30-degree angle is my building block. Figured out that that was 4. Now across from my 60 is my building block of 4 times the square root of 3. 4 square roots of 3 is that piece of this triangle, but it's congruent to the other side. So 4 square roots of 3, back on my original diagram. If I add these together, I get 8 square roots of 3. And I can label this side 8 square roots of 3 as well, because all of my sides are congruent. So let's see. I have my apothem. Well, I should write that in. It is 4. I have my perimeter. I'm good to go as far as filling in my equation. All right. Area equals apothem 4 times a perimeter of 24 square roots of 3. And all of that divided by 2. So I'm going to go to my handy-dandy calculator, and I get 48 square roots of 3. Do I have a unit of measure? No. Units, squaring it because it's area. And that is going to be my final answer for the area of this equilateral triangle. Going on to number 3. I've got a regular hexagon, 6 sides, with an apothem of 2 square roots of 3. I'm not going to do anything different, guys. I'm going to draw a hexagon. I'm going to label it. We are going to pretend that Miss Hart can do a regular hexagon. So from the center to a side, making a right angle, bisecting each side is that apothem. Okay. I have the apothem. I'm going to draw in a radius. Now I'm going to pull out that right triangle, and I've made it too small here, so I'll do a better job of the right triangle of being able to label my apothem. So here we go. Got an apothem, up and down, 2 square roots of 3. Here is my right angle. And I drew in this radius, but again, I need one of these angle measures to help me out. Okay, I've got a 6-sided closed figure. The sum of interior angles is number of sides minus 2 times 180 degrees. So 6 minus 2 times 180 degrees. 4 times 180 degrees gives me 720 degrees. That is everything added up on those interior angles. But I only want one angle, right? I want this angle here so that I can cut it in half with that radius. All right. So the measure of one interior angle, and I'm going to call it I angle, interior angle, equals the sum of all of it divided by how many I have to divide it by, or 6. I've got 6 angles, 1, 2, 3, 4, 5, 6. I'm going to divide this 720 evenly by 6, and I get a final answer of 120 degrees. That angle is 120. But what is that part? That radius cut it in half. 120 divided by 2 is 60, leaving me 30 degrees for this upper angle. And now I'm going back to my 30, 60, 90. Right? Across from 30, my building block, I don't have anything. Well, shoot. Across from my 60 is something times the square root of 3. Something, 2 times the square root of 3. If that's my building block x, then I can fill it in across from 30. 2. This side length, this partial side length here is 2. So the other side of that is 2. Each of these sides is 4 units. Okay? So now I have the apothem. I have my side measures. I can go to my area equation. Area equals apothem, 2 times the square root of 3, times the perimeter, 4 times 6 is 24, divided by 2, equals, I'm going to reduce that fraction, 24 times the square root of 3. I do not have a unit of measure, so units squared, because it is area. And those are the 3 examples I wanted to show you for how to find the area of a regular polygon using the apothem and radius. Thanks, guys.